So, hello everyone. Let's solve MEXT.Math.B 2014 question 3, okay? So, he's telling you consider this function, consider a function y. I'm going to write it if you can't see it well. Fill in the blanks with the answer to the following questions. So, it's a question of 3 parts. The first part is the simplest. Let's start solving it. So, the function that he gave you is y is equal to 8x minus 9 multiplied by 4x, 4 to the x power, and 8 to the x power, okay, not 8x like I said, 15 multiplied by 2 to the x power. So he's telling you that consider big S, so the big S, x, big X is equal to 2 to the x power, okay? So he wants us to say y in terms of big X, okay? So this is what he wants. So just so that we have it colorful, I think it helps to have colors, right? So now so look, y is equal to 8, but 8 is equal to 2 to the third 3 power, right? 8 is equal to 2 multiplied by 2 multiplied by 2. Okay, so 2 to the 3 power to the x, to the small x, right? Okay, so minus 9 multiplied 4 is 2 to the 2 power to the x, right? Plus 15 multiplied by 2 to the x power. Now how do we go on solving this? Remember, this just multiplies, right? So I'm doing it slow because just to make sure that everyone's following on. So 2 to the 3 to the x minus 9 multiplied by 2 to the 2 multiplied by x plus 15 to the 2 multiplied by x. Now look, 2 to the x is big X. So how do we represent this? So over here, so y is equal to, this part over here is big X. So big X to the 3 power minus 9 multiplied by big X to the second power plus 15 to the x power. Look, what am I trying to say? Look, we had, for example, 2 to the 2 of x, right? What I'm saying is that 2 to the x power to the 2 power, but this is x to the 2 power, right? So this is what I'm doing, okay? So basic mathematics. So now this is saying y in terms of big X. So we already answered one part of the question. Okay, so we already answered the part 1, okay? He asked us this. Okay, so now let's go to the part 2. So now he wants the local maximum is at what? So now calculate the local maximum and minimums of y and the value of x. So now I'm going to derive this function. Remember, whenever we are talking about maximum and minimums, we take the derivative. Like, let's say, remember, if we had a graph, let's say that this is the function y, okay? This is y. So if you derive it, what do you find? When you derive, you find the slope, right? The slope at each point. If you derive y, comma, you derive y, you get y, comma, and equal to 0, you will find the slope when it is 0. So you will find maximums and minimums. So let's find y, comma. The derivative is equal. A polynomial derivative, the most simplest, right? You can even memorize it. So 3x squared minus 2 multiplied by 9 is 18x plus 15, right? So now we are going to say that in max and minim, the y comma is equal to 0, right? So 3x squared minus 18x plus 15 equals 0. So now let's solve this quadratic formula. Remember, minus b plus or minus delta divided by 2a, being delta equals to b squared minus 4ac. This is a, this is with the negative, this is b, and this is c. Okay, so this is what I'm going to do. So minus b plus or minus square root of b squared minus 4 multiplied by a multiplied by c divided by 2 multiplied by a. Okay, so let's go on solving these numbers over here. So 18 plus or minus, now this part over here you will need to do it like 18 multiplied, so I'll just look over here so that we don't take too long. So it will be the square root of 12 divided by 2 multiplied by 3 is 6. No, sorry, this will be the square root of 144, right? Look, 18 squared is 324. Okay, 4 multiplied by 3 is 12. 12 multiplied by 15 is minus 118. Okay, so 324 minus 118 is 144, right? 144. So divided by 6. Now 18 plus or minus 12 divided by 6. So now the answers that we can have, 18 plus 12 is 30. So we can have that one root is equal to 30 divided by 6 is 5, or we can have that 18 minus 12 divided by 6 is 1. So we have two solutions, right? We have two solutions for our derivative. Okay, where was our derivative function? Over here. This is our derivative function. Okay, so we did find two solutions. How can we know which one is minimum and which one is maximum? Look, like this is the function, for example. Okay, so for example, here's 1 and here's 5. Maybe this is a max and this is a minimum. Maybe it is like this. We don't know, right? So how can we check it? You can do the second derivative, or you can just substitute. What do I mean? Let's in the main function, you need to substitute in the main function to find the y value. Okay, so this was our function of y. Let's test the x's to find which one of them is minimum and which one of them is maximum. I think it's later we'll do it by the second derivative too. Okay, so for x2, y will be equal to, when x is 1, because it's the easier one to do, so 1 minus 9 plus 15. So 16 minus 9 is 7, right? So y is equal to 7. So we have this point over here. When x is 1, we have it 7. Okay, now let's test when x equals the other root over here, x equals 5, right? So let's test x equals 5. So 5 cubed is 25 multiplied by 5, which is 125, right? Minus 9 multiplied by 25 plus 15 multiplied by 5. So this is the value of y. So y will be equal to minus 25. So our second point over, let's write it over here, is 5, and the point will be minus 25. So this is going to be the second minimum, right? Let's just do this count over here so that we make sure it is right. Actually, I'll do it later to make sure, okay, that I'm doing it right, but so that we don't take too long. So look, when it is x, we have a minus 25, and when it is 1, it's 7. So this is the point of minimum, and this is the point of maximum, okay? So what is he asking us? The local maximum is, okay, so the local maximum is at 7. Remember, let's actually don't need to do this. Look, our points were 1 and 7 and 5 and minus 25. So the local maximum is 7 when x is 1. X is equal to 1. The local minimum is minus 25 when x is equal to 5. So this is our answer over here. This is our answer for question 2, the local maximum and the local minimum. Now he wants the global maximum, right? Now he wants the global maximum and minimums. So look, what I interpret by this is when he's talking about the local, he's talking about what this function over here, okay? And when he said the global, we are talking about this. Later I'm going to show a graph of them both, okay, just so that we can understand better. But and first let's just say which one of these are minimum and maximum with the second derivative, okay? So where is the first derivative? Where is the first derivative? Here, the first derivative. So the second derivative is deriving the first derivative. If you can do the first derivative, you can do the second derivative easy. Okay, no problem. So y2 is equal to 6x minus 18. So look, how can we know which one is the second derivative and first derivative? So we will test. If we will put in y2 the 1, and in y2 the 5. Why? Because these were the axes of maximum and minimum, and we want to know which one of them is maximum and minimum. Now this might not seem like intuitive, but the maximum point, it will be a maximum when y2 of an x is smaller than 0, then we have a maximum, and you will see this. And when y2 of an x is bigger than 0, we will have a minimum, okay? And here a max. Why is that? Look, if you have like this function over here, okay? Now, if you do the first derivative, you will find the slope of this function, okay? So, and then you say it is equal to 0. It is equal to 0 in this point, so that you can find the maximum. If you derive this, the derivative function that tells you the slope of this one in each point, okay, you will find how the slope of the derivative change, right? The slope of the derivative behave. So if you want the slope of a maximum point, it must be smaller than 0 in that point, because it's going to go down, right? And when it's maximum, it's positive. It's going when it's minimum, it's going upwards. So if this doesn't make any sense, there's no problem, okay? You can always just substitute like I did to find them, okay? So these are our values, okay? And just so that we do it. So in y 2 comma of 1, if we write it like this is better, okay? F of x of 2 comma is equal to 6 multiplied by 1 is 1 minus 18, right? This is equal to minus 12, okay? A negative number, it is smaller than 0. This is why it is a maximum, okay? A local maximum. See, a local maximum. Remember, don't confuse this minus 12, okay? This is just telling you that it is negative, so you have a local maximum. And of 5 you will have that 5 multiplied by 6 is 30 minus 80 is equal to plus 12, right? So you have a minimum because it's positive now. Or like you can forget everything I said in the last 4 minutes or so and just substitute, okay? There's no problem at all. So now let's go to the global maximum and minimum. So when we are talking to the global maximum and minimums, as it is an x from infinity to minus infinity, so I think we are talking about this function over here. So look, remember that big X was equal to 2 to the x power, right? When was x maximum? Well, it was maximum when x equals 1, right? So when big X equals 1, let's find this x maximum is equal to 2 to the x power. So for 2 to the x power equals 1, then the small x must be equal to 0, okay? Because 2 to the 0 power is equal to 1, right? Any number to the 0 power is equal to 1. And if we want to find the local maximum, let's put over here the 0, right? 8 to the 0 is 1. So let me just... So the global maximum is when y 8 to the 0 is 1 minus 4 to the 0 is 1 multiplied by 9 is 1 plus 2 to the 0 is 1 multiplied by 50 is 15, and 15 plus 1 is 16 minus 9 is 7, okay? So y of the maximum global is 7, okay? So we will have our point of the global maximum 0, 7, okay? So this would be the first part of the third part, the first part of the third part of this question, okay? So the global maximum is 7 at x equals 0, okay? And the global minimum, well, the global minimum is, remember where it is, here. The global minimum is when big X equals 5, right? The local minimum. So look, x is equal to 2 to the x power, right? So when big X equals 5, we will have a minimum. So let's find 2 to the x. How? This value over here. We want to find x. Now we are going to use log because we want the value of x, not 2 to the x, right? So log of 5, and we are going to use it in the base of 2, okay, so that we can cancel this 2 over here. You will see like what. So log of 5 in the base of 2. So if I use log in the base of 2 over here, we need to use it in the other side, right? So log of 2 to the x in the base of 2. So log of 5 in the base of 2 is equal to, now x is in the exponent, goes multiplying, log of 2 in the base of 2, which is 1, right? This is 1. So multiplied by 1, so log of x. So this is small x, okay? This is small x. So the small x minimum is equal to when log of 5 to the 2, okay? So this is the log of x minimum. Now we need to find the global minimum, right? How can we find it? Well, it might not seem a good idea, but we are going to copy this and we are just going to put the value of log of this small log of x minimum. So Look, y is equal to 8 to the x power, right? So, but x is log of 5 in the base of 2, right? X is equal to this, minus 9 multiplied by 4 to the log of 5 in the base of 2 plus 15 multiplied by 2 to the log of 5 in the base of 2. Okay, now remember, 8 is 2 to the third power. Okay, now again, log of 5 to the 2 minus 9. 4 is 2 to the 2 power, log of 5 to the base of 2 plus 15 and multiplied by 2. And here you need to remember the property. If you have a number a to the log of b in the base of a, you can say that this is just b, right? Because this is in the base of a and this is a. So this is just a reminder, okay, of a logarithmic property. Okay, and here it is a. Okay, here is a. So an a. So this is just, let's just put it over here, just a property for us to remember. Okay, so log of 5 in the base of 2, log of 2 to the power of log of 5 in the base of 2. Well, this part over here will be only 5, right? It's like cutting like this and then the 5 comes down, right? So this is what I'm doing. Okay, so here I'm multiplying by 5. Okay, and now I'm going to do the same for this over here. What do I mean? Well, 2 to the log of 5 in the base of 2 to the third power. I just changed their positions. Why? Because now I can cancel them over here, right? To the third power minus 9 to the 2 log of 5 in the fifth power in the base, log of 5 in the base of 2 to the second power plus 5 multiplied by 5 is 25. 5 multiplied by 1 is 5. Plus 2 is 7. Okay, this is just 5 multiplied by 15. Okay, so now we will have that this will cut because of the property I just showed you. So 5 cubed minus 9 multiplied by 5 squared plus 75. Now 5 cubed is, I think we already did this. It gives us minus 25, right? 5 cubed is 125 minus 9 multiplied by 25 plus 65. And let's just do 25 multiplied by 9 over here. 9 multiplied by 5 is 54. 9 multiplied by 2 is 18. So 225. So 125 minus 225 plus 69. So this, so I said 69, I think over here it's 75. Okay, 75. So by doing this over here you will get minus 25. Okay, let's just cut this parts over here. So you'll have minus 25 when x was equal to what? Remember, this x over here, okay, this is the global one. Okay, so and the y, the global maximum, is minus 25. Okay, so this is our answers. Okay, you put it over here. The this is global minimums, right? We already found the global maximum. This is the small x of the global minimum and the y of the global minimum. The global maximums, where are they? Where are they? Where are they? Here, 0s and 7. 0 and 7 global minimum. Just to make sure everything is right. Global maximum. I keep. These are global maximums, and that was the global minimums. And then here we found the maximum and minimums, the local ones. Okay, so this is it. I'm going to show the graphs now. So here we have f of x, which was the first equation that he gave us. I put the name of g of x for the second one when we substitute big X is equal to 2 to the 2x. So, and h of x is the derivative of g of x, okay? So let's now just focus on f of x. Look, f of x has a maximum in this point over here, 0 and 7, okay, and a minimum in this point over here, okay. So this 2.33319, this was the log of 5 in the base of 2, remember, and in minus 25, okay. So this was the local maximum, the global maximum, and the global minimum. And now let's look to g of x, which was when we put the other name. So it has a maximum in 1,7, okay, 1,7, and the minimum in where? 5 and minus 2, 5, just as we did use it, right? Now, just if you're not familiar with the derivative, remember, the derivative is just giving you a slope, and we said that it is equal to 0 because we wanted this point over here. Look, this has a slope. The slope is equal to 0. So this is what we were doing, okay, when we said that the derivative is equal to 0. Okay, so this is g of x. Now, to be honest, I had a doubt because the way he said, like, the global maximum, so it was a bit weird for me, like, the global maximum, like, I didn't really understand what he meant, because it goes to infinity, right? So it made me a bit confused. So now let's see, just to see the derivative function, okay? So look, you see that this purple one, the purple one, is the derivative of the function the red function. Look, where when it cuts the x-axis, when it has when in this points, right? So when the red one has a maximum point, we have that the purple one is cutting the x-axis, right? Look, the purple in the x1, it's cutting the x-axis, and here it's cutting again. And what do we have down here in the 5? We have a minimum point. So when the derivative function was equal to zeros, we had we had minimums and maximum points, okay. So this is